Hi, and welcome to our first AdaPi YouTube tutorial. Don't forget to like, subscribe and hit that notification bell, because in the future we'll be releasing more videos regarding stake pool operation and development on Cardano. Also, don't forget to take a look at the adapi.io website, where you can find a link to our GitBook, where you can find tutorials about how to set up a stake pool on your Raspberry Pi, as well as other useful tutorials. My name is Olivier and I'm running the SBLYR stake pool. And today we will be looking at how to create a NFT on the Cardano blockchain. To follow along with this tutorial, you need to make sure you have a basic understanding of programming, and you should have Cardano Node and Cardano CLI together with Node.js already installed on your machine. Instructions on how to install Cardano Node, Cardano CLI and Node.js can be found in the description of this video. We will be using the Node.js package Cardano CLI Yes, made by Alessandro from the Berry pool. This is a basic wrapper around Cardano CLI and will make the interactions to create the native asset a lot easier. Okay, now let's assume that you have everything installed, and then we can go ahead and start this tutorial. Okay, now let's check if we have both Cardano Node and Cardano CLI installed at version 1.26.1. Now let's check our Node version. Let's make a directory called minter. Change to the directory minter, do npm init-y, then npm install Cardano CLI-gs. Now the right dependencies should be installed. Okay, now go ahead and enter this URL. You can find it in the description. This takes a while to load. Then the build number should be in there. Okay, now let's make a bash script that will download our config called fetchconfig.sh. Let's put in the node build number 5821110. Now let's do wget-n and put in the link. You can find it in the description as well. Now go ahead and change the permissions of this file so it can be actually executed. Let's execute it. And there you have it, your config file. Okay, let's make a directory called src. Create a new file called cardano.js. Let's import Cardano. Then create a new instance of Cardano. Then we have to specify the network. In this case we will be using mainnet. Define the directory where our output will go. That will be one level above src. And then we can specify our Shelly Genesis path. That will be the path to our mainnet Shelly genesis.json. Okay, and then let's export this Cardano instance. That way we can import this into our other scripts. Okay, now let's create a script that will create our local wallet, which we will be sending funds to. So we import our Cardano client instance. Then let's create a function called createWallet. First let's do address keygen. This will generate both a public and a private payment key. After that we will create a stake public and private key as well. Then we will build a stake address. Together with the payment keys and the staking keys, we can create a wallet address, and then we return the wallet if we would like to execute commands on the wallet. Okay, now let's just execute the function and give the wallet a name that we will pass to each of these functions. Let's call it AdaPi. Okay, now let's just go ahead and execute the create wallet function. And this in turn should create a private directory with both the staking and payment keys in there, as well as the stake and payment address. Next, we should be sending real ADA to this payment address that we have just created. So this is our local wallet payment address. Now let's create a file named getBalance to see what the balance of this address is. So we should import Cardano again. Then open up our wallet. And then output the actual balance of the wallet. Let's now execute the script to see what our balance is. It should be empty. Yeah, we don't have any balance right now. Let's send some real ADA to this address. It can take a bit for the ADA to arrive, but let's check our balance. You can see 9 ADA has arrived that we can now use to mint our asset. So first we'll get the wallet, so we can get the actual balance of the wallet and the UTXO, which we'll be using to define our transaction. Then we will define the mint script. You can read more about the actual mint script on the Cardano website, and we'll put a link down below. Then next we'll create our policy ID, our asset name, and then together with our policy ID and our asset name we'll create an asset ID. So the policy ID is unique to your wallet, and the combination of both the policy ID and the asset name is unique. So another person can create a wallet and then use the same asset name with a different policy ID. That's why you most often see when someone sells NFTs that they will say to you to check the policy ID if it matches theirs, because if it doesn't match theirs, it's not the actual NFT that they minted. Okay, so now we can define our metadata for our NFT, which will contain the name of the NFT and the image and perhaps some other information. Then we can define the transaction. We will put the metadata in the transaction. We will then build the transaction, calculate the fee for the transaction, sign it, and then finally submit the transaction. Okay, now let's get our wallet. I made a mistake by calling this wallet, and it should be named receiver. I will change that later on in the video, but you can go ahead and change that to receiver right now. Then we import our Cardano client. Next, we will define our mint script. It will contain the key hash of our wallet together with a type that is now called SIG. There are different mint scripts that you can define. Again, you can look them up in on the Cardano website. Next, we will obtain our policy ID by passing our mint script to transaction policy ID. Then we will define our asset name, which will be called berry space green. You can name it whatever you like. Next, we need to put together the policy ID and the asset name concatenated with a dot. Okay, now comes the interesting part, the metadata. First, we will define 721. That's referring to the 721 ERC standard of Ethereum. I've put a link down below where you can read more about this format. And then the next property we define is the policy ID, followed by the asset name property, and then the actual NFT metadata object will be defined with the name of the asset and the image of the asset. The image will contain the reference to our thumbnail image stored on IPFS. This thumbnail image then can be used to display it on any website that would like to display the NFT without having to display the original file that can be larger in size. The recommended size for the thumbnail image is lower than 1 megabyte, so that it can be easily displayed on websites, because your original image that you will put in the SRC property will contain the full image, which can be large in size. The description is optional, and the type should be the MIME type of the original image you are using for the NFT. Besides that, you can also add other properties that are not part of the standard that you would like to add. Of course, you can also change the MIME type to be like a PDF document or a video. You should place that files on IPFS as well, but the NFT is not limited to just an image. You can upload any kind of file. Of course, the thumbnail, the image properties should still contain the thumbnail to that document. So it can be a PDF document or a video, and then it can still have a thumbnail image. Okay, next we define the transaction where we'll be passing the output of the wallet, and we'll be creating a new output where we specify the address of our wallet with everything that the wallet contains plus our non-fungible token. We do that by specifying our asset ID as a property, and then we will pass the value of 1, making it a non-fungible token because it has a supply of 1. If we were to increase the amount 1 to, let's say, a higher number, then we would be basically creating another currency and making it a fungible token. Okay, next we define the mint action with an amount of 1, and again our asset ID. That's just how this library works, and it will pass the appropriate params to the underlying Cardano CLI. And then we will be adding our metadata we defined previously and a witness count of 2. Okay, next we will define a function that will build our transaction. It will take one parameter, that's our transaction that we have defined. Then we will be building the transaction first in a raw way that will create a TX body output. Then we calculate the fee that has to be paid for the transaction using that raw transaction. And then we will be updating our transaction and subtracting the fee from our amount that will be in the output for our address. And then we will be building the transaction again based on those changes. Okay, next we will actually call this function and create the actual transaction. And next we define the sign transaction function. It will take the wallet, the transaction, and the mint script. Next, because of the witness count being 2, we will pass the private key of the wallet 2 times. It's also called the signing key. Then, as the script file, we pass our mint script we defined earlier, and then we pass the transaction. Now let's actually call this function that we've just created. And pass the appropriate params. Okay, now we actually have the signed transaction. The next step is to actually submit the transaction. When we submit the transaction, we will receive a transaction hash that we will be outputting, and that hash you can in turn put into Cardano scan or whatever tool you like to follow transactions on the blockchain. And now let's execute the script and mint our asset. And you see we have our transaction hash outputted here. When we get the balance, we won't be seeing our NFT yet because it takes time for the transaction to be propagated through the network. So we will wait a little and come back once the transaction actually has been propagated. Okay, now let's run our getBalance script again, and you will see we have the NFT. Okay, now let's send back our NFT that we have just created to our Daedalus wallet. So we'll be first importing Cardano client again. We then get the wallet. We'll define the transaction, build the transaction, calculate the fee that should be subtracted from the amount in the output. Then we should build the transaction again. Then we will sign the transaction. And lastly, submit the transaction. Okay, so now let's start with getting the wallet. Just like we did before. ADA Pi. Let's define the transaction. So we first specify our wallet address of our Daedalus wallet. It can be any wallet, of course. It should be your address where you want to send the NFT. Then we pass the output of our wallet. So in the first output, we will be defining what the output will look like for the sender wallet. So we will define the sender wallet address. together with the amount that will be left in the wallet after we've done the transaction. So the amount of Lovelace should be the current balance. And then we take off a minimum of 1.5 ADA. It depends on how much metadata you're sending alongside the transaction. That number should then be increased, but you should generally not go lower than 1.5 ADA. That's the minimum that has to be sent alongside with the NFT or any native asset. In the future, it will also be possible to pay the transaction in like a native asset. You can read more about that on the Cardano website as well. It's called Babel fees. In the next output, we will define the receiver address we've just specified above, together with the amount of Lovelace that the receiver will receive, and our native token with the amount of 1. And also let's just log the balance of the wallet so we can actually see what's in the wallet before we create the transaction. Okay, now using this information, we will create the raw transaction. Okay, next, based off the raw transaction, we'll calculate the fee. Calculate minimum fee. Pass the transaction information, the raw transaction body, and the witness count, in this case, of 1. So for the minting transaction, you will actually need a witness count of 2. Both the sending and the receiving wallet should sign the transaction, since the minting parameter will be passed. But for sending of the native asset, like we will do now, we can just, like any regular transaction, pass a witness count of 1. So next we will subtract the fee from the amount of Lovelace that will be inside our wallet after the transaction will be submitted. And then we will build the transaction again. We'll sign it and then submit it. I actually made a mistake by mentioning changing wallet to sender in the previous transaction. That should be in this transaction. So sorry for that. Then we will execute send asset back to wallet, and you will see that we now left with 8.8 ADA and the transaction hash that we can then look up in our wallet. And in our wallet in Daedalus, you will see now that we have the Berry Space Green NFT. We just received it. If you would like to send the NFT to another wallet, that again is possible, but you should be adding at least 1.5 ADA, or in this case, we will not have enough ADA to send it to another address, but you see you can select the token there. So in my case, I should be adding more ADA before I want to send this NFT to another wallet. Okay, now let's take a look at Cardano scan and pass our transaction ID. And you will see that this is the transaction. And there you see the berry space green NFT. And there you can see the policy ID, and you can see all the other tokens for the same policy ID as well. So if you will make another NFT using the same local wallet, it will be added to that list. And you can also follow on the mint transaction. That's the original transaction where our metadata will be displayed. You can open that, and then you see the metadata with a label of 721 and our metadata there. We can copy our original source reference on IPFS and open it, and then see that our image is there. Okay, let's have a look on Pool PM. Enter our address from our wallet. And then you can see our NFT is now there. It can take a little time to show up, but you see it is displaying our thumbnail image and the rest of our metadata. Thanks for watching, and if you like these tutorials, please consider delegating to our pools. You can find the tickers in the description. And we want to give a special thanks to Alessandro from the Berry Pool for creating the Cardano CLI ES package that enabled us to create this tutorial. If you have any questions, you can comment down below or join our Discord channel. Thank you for watching, and until the next tutorial.